Okay, this is lesson 4.2, graphing inequalities in two variables. In Khan Academy, under the Math 1 section, we're working in Unit 7, Inequalities, and the Khan skills associated with this lesson are skills 4 through 6. Okay, at the end of the last video in 4.1, I showed you how to take an ordered pair and see if it's a solution to a two-variable inequality. All you need to do is take your x number and your y number and substitute it in and ask yourself, is that inequality true or not? So try these on your own, pause the video, and then come back and check your work. Okay. There we go. We took our x number, our y number, plugged them in, and then when we follow the order of operations, 2 times 4 is 8. 8 minus 3 is 5. And we're asking ourselves, that's why I have the question mark here, is 5 less than 4? And no, it's not. Since this statement is false, we can conclude that 4 comma 3 is not a solution to the inequality that we were given. Similarly, if we do the same thing for the second point we were given and plug it into the second inequality, we end up with 0 is less than 0. This is strictly less than, not less than or equal to, so it's false. The point is not a solution to the inequality. Okay, before we move on, I want to remind you that back in chapter 1, we had one variable inequalities. Something like when you solve it, you get x is less than 7. Let's make that less than better. There we go. If I asked you to graph this, we would graph it on a number line, right? We'd mark our 7, we'd put a tick mark above or below, something like this. And then we would need to make a boundary point. Since x is less than 7, our boundary point is going to be 7. And it's going to be an open circle because we're not including 7. After that, we need a test point. Let's test 6. Is 6 less than 7? Can 6 take the place of x? Yes, it can. So that's why we shaded to the left or drew an arrow to the left. If I chose 8 as my test point, can I put 8 in the place of x? Is 8 less than 7? No, it's not. So I know that I can't really shade to this side. I have to shade to the other side. That's going to be important in this chapter as well. So for two variable inequalities, we're going to use this new rule. Remember how we had a number line in one variable inequalities because we had one variable? Well, now we have two variables, y and x, and guess what? We have a number line for x and a number line for y, and together they make a coordinate plane. It's no longer one dimension, it's two. But the idea is the same. We have to find a way to mark all the solutions on this plane the same way we chose to mark all the solutions on the number line. Okay, so let's get right down to it. Our first step, if we're graphing this inequality, is that we need to change it to slope-intercept form. Intercept form. So again, that's y equals mx plus b form. I didn't put equals this time because we're not working with equalities or equations. We're working with inequalities. So it's going to be like less than or greater than. But y is going to be on the left. Mx plus b is going to be on the right. For the example that we're given, we already have it in slope-intercept form. Our next step is to graph the boundary line. just like we had a boundary point in one variable, we're going to have a boundary line in two variables. So because we got it in slope-intercept form, we know that the boundary line is going to have a slope of -1 and a y-intercept of -3. So we've graphed lots of lines by now. Let's go down to -3, the y-intercept. That's our starting point. And then our slope is -1. We can think of it as -1 over 1. So we'll go down 1 and right 1 and put another point. And we can continue that pattern. Or we can go up 1 and left 1. All of these points are on our boundary line. One thing I did not do yet is I did not draw the line. There's an extra step here for inequalities. If it's strictly less than, I guess it's strictly greater than or strictly less than, then we need to draw a dashed line like this. That's to signify that the points on the line are not included in our solution set, just like we used open circles to show that that point is not a solution. However, if it's greater than or equal to or less than or equal to, that's when we can use a solid line, which would be analogous to filling in that point if it was less than or equal to or greater than or equal to. That means the points on the line are part of the solution. Since we have a less than or equal to, we can draw our solid line to show that all the points on the line are solutions. And then the last thing we need to do is shade. We're going to shade one side of the line, either above or below the line. And the first way I'm going to show you is using a test point. The only rule is the test point cannot be on the line. So let's use a test point that's not on the line. Any chance I get, I use the origin, 0, 0, because zeros are nice numbers to work with. Let's check our test point over here. Something like that. And we're going to plug in 0 for y and 0 for x into this equation, or inequality. So is 0 less than -0 minus 3? Well, -0 is just 0, and 0 minus 3 is -3. Is 0 less than -3? No, this is false. So I know that I'm not going to shade on this side of the line. I have to shade on the other side of the line. Now on your paper, you probably are just using a pencil, so you don't need to do anything fancy. You could just scribble on that side to show me that's the side that you're working with. But because I have a highlighter, I'm going to highlight the part of the plane that has our solutions. All of these points in this green highlighted area are solutions to the inequality. Now, the last thing I want you to write in your notes is this, or you can use the shortcut, which I will explain at the bottom of this page. Let's try one more together, and then you can try one on your own. This inequality that we are given is not in slope-intercept form. So let's get it in slope-intercept form. Take x from both sides. And then we need to divide both sides by 4. And then I need to ask myself, am I dividing by a negative? No, I'm not. So this stays greater than. And we're left with y is greater than -1/4 x minus 5. There's slope-intercept form. We have our y-intercept, and our slope is -1/4. So I can go down 1 and right 4, or I can go up 1 and left 4. There is no or equal to, right? It's strictly greater than, so I have to use a dashed line. Finally, I'm going to use a test point here. So I could plug in 0, 0, 0, because the origin is not on the line. So is 0 less than, or I'm sorry, is 0 greater than negative 1/4 times 0 minus 5? Is 0 greater than negative 5? Yes, that's true. So we're going to shade all the points above the line. All right. I want you to try this last example on your own and then come back and check your work. There we go. So it's already in slope-intercept form. There's our y-intercept, and then our slope is negative 6/5, which gave me that point. It's a dashed line because it's not or equal to. And when you plug in the origin, you get a true statement. So we shade to the side that contains the origin. All right, I want to show you the shortcut, but I'm hoping you can guess the shortcut if I show you these 3 examples. Did you notice that when we had a less than in slope-intercept form, in this case, we shaded below the line. And again, this was a less than, we shaded below the line. But this one doesn't necessarily count because it's not in slope-intercept form yet. But once we got it in slope-intercept form, we had a greater than. And notice we did not shade below the line this time. We shaded above the line. Maybe you can guess the shortcut, but I'll go ahead and write it out for you either way. If we have greater than or equal to in slope-intercept form, then we're going to shade above. If we have less than or equal to when we're in slope-intercept form, then we need to shade below. Awesome. On the next page, we have a word problem. So Mr. Kelly and Mr. Brust are raising funds for a big trip to Graceland. Mr. Kelly makes about $15 for every hour he works, and Mr. Brust makes about $5 for every hour he works. They figure they need to make at least $100 to go. Okay, so we got Mr. Kelly making $15 an hour, and we have Mr. Brust making $5 an hour. Oh, and they need at least $100 to go. So what we're going to do is we need an expression using variables to represent how much money they make. And because they need to make at least $100, I'm going to say greater than or equal to 100. The money they make needs to be $100 or more than $100. Okay? And then we don't have any variables defined yet. Let's define some. Let's let X be Mr. Kelly's hours worked. And we'll let Y be Mr. Brust's hours worked. Awesome. And if we do that, then Mr. Kelly is going to make $15 for every hour, for every X. So 15 times X would be how much money he makes in dollars. And then we're going to add 5Y to add how much money Mr. Brust makes for every Y, for all the Y hours that he works. Then we need to graph it. And it is not in slope-intercept form. So let's take 15x from both sides of our inequality. There we go. We'll get 5y is greater than or equal to negative 15x plus 100. And if I divide both sides by 5, I'm dividing by positive 5. So the inequality does not change directions. And I'll be left with negative 3x plus 20. I divided everything by 5. Now I'm in slope-intercept form. The y-intercept is 20, and the slope is negative 3. So down 3, right 1, and I can continue that pattern, down 3, right 1. And it's greater than or equal to, so I can draw a solid line. There we go. something like that. And then if I plug in 0, 0, is 0 greater than or equal to negative 3 times 0 plus 20? Or is 0 greater than 20? That's false. And this should make sense because they can't both work 0 hours and be able to afford the trip, right? So we need to shade all the points above the line. Everything above the line is a solution because if they work more than the hours, they'll have more than $100, right? Okay, the last question says, what are 3 possible combinations that would allow them to go to Graceland? So really, we just need to list 3 ordered pairs. For example, this one right here, that y-intercept. If Mr. Brust works 20 hours, he makes $5 an hour, so he'll make $100, and then Mr. Kelly could do nothing. They'd make enough to go. Another one could be up here. Mr. Brust could work more than 20 hours. Mr. Kelly wouldn't have to do anything, and Mr. Brust could work 22 hours, and they'd have at least $100. They'd actually have more than $100. Any point in the shade, all of these points work. Just pick 3 and list them in your notes. Notice this one here. If Mr. Kelly wanted to work instead and let Mr. Brust take a break, then Mr. Kelly would only have to work 7 hours. And he'd already make, notice how this is not on the line? That's because 7 times $15 an hour is more than 100. But there are 3 possible combinations. You can list your own. You don't have to list mine. All right, last one. Try this on your own, and then come back and check your work. There we go. I took the given inequality, and I got it into slope-intercept form. Our y-intercept is -3. Our slope is -5/4, but I could not go down 5 and right 4 because I lost room. So instead, I went up 5 and left 4. That's the same slope. It's a solid line because I have the or equal to line. And then because it's less than, I shaded below. That's it for 4.2. Don't forget to ask a question at the end of this video. Do your con skills, and I will see you all in class.